I'd like to take a moment to talk about interpreting the correlation and some things we need to be careful about. So first, I'd like to talk about how values can be greatly influenced by the range of scores. So you can see on this pretend data set here that I have this line kind of blocking off sets of data. Let's say that I have age predicting, I don't know, let's say how many friends you have. Now, maybe I wanted to measure everyone, but let's say that I wasn't allowed to ask anyone under the age of 18 because I'd have to ask their parents. So this is the line marking 18-year-olds and up. And if I look at how many friends 18-year-olds and up have, you see how the data seem to look like there's nothing there. There's really no pattern. If I were to calculate a correlation coefficient, it might tell us that there is no pattern. And I might erroneously conclude then that the older you get doesn't really predict any change in friends. However, if I could have looked all the way back at birth, I might have seen that the older you get, the more friends you have. But I missed out on that picture because I didn't record anyone of the younger age. So that's something to be careful about with our interpretations, is that you may be artificially looking at just one section of the distribution and losing sight of the entire relationship. So if you are reading a paper that has some kind of marker or start point that doesn't include the entire range, you may need to consider that they have some error in their interpretation. And this can work the other way too. Let's say this is the same idea of age and number of friends. And when you look at the entire picture, there clearly is no relationship between age and the number of friends. But if I start only at 18-year-olds, this cluster of dots is just a random piece of a larger random set of data, but it just happens to look like there's a very strong relationship, that the older you get, the more friends you have. And so this could be reported as well, and this person, the researcher, would have missed out on the entire picture, which really indicates that there's no relationship. Now, of these two graphs, A and B, I want you to think about which one are you more likely to read about in a publication. Hopefully you're remembering that you're more likely to read B because they found a significant relationship between age and friendship, and they would have been wrong. This one's unlikely to be published because they found no relationship between the two. However, both are possible, and so I want you to consider that if you're ever reading a paper, especially if they're looking at age or something where they have to start at an arbitrary point or they can't go all the way down to zero, how this big picture might be looking, because all they're showing you is this chunk here. Another thing we want to consider is, for correlations, how it can be influenced by outliers. So let's say that we have this pretend data set, and just for fun, we can say it's how many years you've known me, predicting how funny you think I am. And you can see the correlation is quite small, 0.08. That means there's no relationship between how many years you know me and how funny you think I am. But then let's say, I want to highlight that the correlation then again would show there's really no relationship, would be a flat line. Let's say then we add my husband to the picture. Now notice all the data here are the same as on the left, but I would just added one additional piece here. Let's say my husband has known me a very long time and he thinks I'm hilarious, right? So this one person, when I add this to the model, it looks like a very strong relationship. I apologize, I kind of subliminally messaged you for another lesson. So it looks like a very strong a very strong correlation between how many years you know me and how funny you think I am, but that's being driven by one individual. See how the correlation went from negative 0.08 to a 0.85. That's a very strong relationship. And so it's a little unnerving to think that you're making your entire conclusion that's being driven by one person. Now, that doesn't mean that you should just automatically ditch that person. I mean, obviously, people don't do studies on their own husbands. But if I were to do a study and this is how the data are, I don't really have a legitimate reason just to exclude this person right off the bat. However, it is weird that they're driving the entire effect. So what I tell students they should do if they're reporting these results is report it both ways. Tell your readers, here's my correlation with everyone included, but when I take that person out, here is my correlation. Let the readers decide what they want to do with that information. But it is important to recognize, and you should be looking at your data to see if it is being driven by one individual. If you just run the correlation without looking at it, you may not have realized that it's one person driving all of that. So the last piece of interpretation that I want to talk about is called the coefficient of determination. And this is to make our data palatable to people who haven't taken stats. If I tell someone that I have a correlation of 0.85, they might not know what that means. They actually might think it's a quite small number because 0.85 is, it's a fraction. They haven't taken stats to realize that's a strong correlation. So what we're going to do is calculate something called a coefficient of determination. So the way you calculate that is you take your correlation and you square it. And so this R squared is the symbol we have for coefficient of determination. Once we've squared it, we now are able to put a magic sentence to that data. But we're really talking about the percent of the variability in our dependent variable that's associated with the variability in our independent variable. And I think this can be helpful to see in an example. So let's say that I looked at years of education and how that predicted your income. Let's say those are correlated with a 0.9. So if I square 0.9, I'm going to get 0.81. So my coefficient of determination is 0.81. Now I can put this into a sentence. It says 81% of the variability in income is associated with the variability in years of education. So I'm going to put that in a picture form to help you understand. So there's a lot of variability in income. Some people make a lot of money. Some people make a little bit of money. I want to understand what is predicting that variability. Let's talk about some of the variables that matter. And let's say this gray circle here is all the variability associated with income. A lot of money, a little bit of money, and then all in between. Let's say that IQ predicts some element of how much money you make. Not everything. It's not the whole picture, but being smart can predict how much money you make to some degree. But that isn't everything. Let's say it's also who you know. If you know someone who's in a business and they're doing really well and they might set you up with a job, maybe your parents, and then they give you the family business, who you know may be a huge chunk of how much money you make. And notice that I had it overlap with IQ a little bit, because if you know someone who has high IQ, because you have a high IQ, that may set you up for a better paying job, right? Let's say there's also the variable of socioeconomic status, SES. Socioeconomic status would be things like, especially if you're an undergraduate, this could be what kind of income you come from, what are the education of you and your parents, what kind of neighborhood you live in. All those things can predict how much money you make when you do get a job. And notice that that would overlap a little bit with who you know, right? Because you're living in the same rich neighborhood of other rich people, and that might predict how much money you make. Let's say we want to look at what college you go to. That's going to overlap with socioeconomic status. If your parents can afford to send you to a better college, then that might set you up for more money earning potential. So see how there's lots of things, and I'm sure I could fill this in with many, many more things. I mean, how personable you are might predict how much money you make, and that might overlap with IQ or who you know. Lots of things go into how much money you will make when you go out into the workforce. But what this variable is saying here is that 81% of this entire circle can be connected to how many years of education you have. So this is my attempt at drawing in 81%. So notice how it overlaps with things like socioeconomic status, who you know, IQ, what college you go to. All I know at the end of the day from my calculations is that all of the variability in how much income you make, 81% of that can be related to how many years of education you have. Now, I'm not saying that years of education caused you to make more money, because it may be these other forces. But I do know that if I know your years of education, I can very strongly predict what your income will be, whether it's the causal force or not. I also want to highlight that I'm not saying 81% of your income is associated with your years of education. So let's just say you're making $100,000 a year. I'm not saying that 81,000 of that is due to years of income, and then 20,000 is due to how happy you are. That wouldn't make sense, right? We're just saying that some people make a lot of money, some people make very little money. The variability between them, 81% of the variability between those people can be related to the years of education. So this coefficient of determination turns this number into something more palatable to other people so that we can, at the end of the day, make a sentence that helps them understand a bit more about the relationship between years of education and income, or whatever variables we're looking at.